So this is the practice test number 3 released by the AP. And this video is going to be the multiple choice questions, the 28 multiple choice questions that that you're not allowed to use a calculator for. Here's a function, and they want to know when is it equal to 256. So the 256 is not the x, but the 256 is the h of x. And I guess the thing they want you to be careful about is not to do 8 times 2 is 16, but instead divide both sides by 8. Now 256 divided by 8 is 32, and then x has to be 5 just because 2 to the 5th does equal 32. Question 2, the figure shows the graph of a quartic, that means 4th degree. How many points of inflection? So points of inflection is when it switches from like a smiling looking graph to a frowning looking graph, or from a frowning looking graph back to a smile. Those are so we can see here is a spot where it switches from smile to frown, and now it's frowning, frowning, frowning. Over here it switches again, so there are 2 inflection points. So that was a question about knowing what inflection point means. Number 3, f of x equals e to the 2x, and 1 is ln 3x. So f of g of x is f of ln 3x, because that's g of x. And then f of x is e to the 2 times whatever's in the parentheses, which in this case is ln 3x. Now, this one's actually a little confusing, because like here, this is the answer, but as you can see, it's not one of the answer choices. So, in general, if you say something like, what's 2 to the log base 2 of 32? Log base 2 of 32 is 5, because that's saying like 2 to what power equals 32? And then if you raise 2 to that power, you would get 32. So if you see something in this kind of form, 2 to the log base 2 of whatever, 97, it's going to be 97. This is the whatever number you have to raise 2 to get 97, and then you actually go ahead and do it. Same thing goes with e. E to the ln of 97 would be 97. So here it looks almost like this, except there's this pesky 2 there. But there's a rule of logarithms that you can move this 2 up to become an exponent. And then you have e to the ln 3x squared, just becomes 3x in parentheses squared, which turns into 9x squared choice A. There's actually a lot to know for that question. Question 4, we have the function f of x equals -1, and the function g of x equals log base 3 of x. And then we want to subtract them, and they want to know the x-intercept. Well, the x-intercept in general is when y equals 0. So if I plug 0 in for the y value, and g of x minus f of x is log base 3 of x minus f of x is -1, so that turns into +1. Now you subtract 1 from both sides. Now, some people might think that they see this negative in logs, but the fact is that you can rearrange any equation that's like log base b of a equals c into b to the c equals a. So if I do that here, I get 3 to the -1 equals x, or x is equal to 1/3. And it's true, log base 3 of 1/3 is -1, and -1 plus 1 is 0, so this is 1/3, 0. Number 5, we have a graph of exponential function b to the x power. B is greater than 0. It's also greater than 1. To have exponential growth, consider the logarithmic represented by log base b of x, of which so first of all, this graph is actually you can see it's going up from 1 to 3 to 9, So it's actually 3 to the x power. And that has on it points like 0, 1, and 1, 3, and 2, 9. Well, the inverse, h of x, is log base 3 of x. Well, that has similar points. For instance, it has 9, 2, because log base 3 of 9 is 2, and it has 3, 1, and it has 1, 0. Basically, the numbers are all switched. The x-coordinate becomes the y-coordinate. So which are on the graph of h, which isn't shown, which incidentally looks something like that? Well, 1, 3, and 3, 9, and 2, 9, those are points on the original. But if I take those points and switch the x and y around, I get points on the inverse graph. And that's why the answer is choice D. Question 6. Here we have a table, and they want to know h inverse of k of 3. They really like these composite functions. K of 3 is 4, so it's h inverse of 4. H inverse of 4 is not 6. You might get tempted. That's h of 4. H inverse is 4. H inverse of 4 is you look for a 4 here and see what the x value was. It equals 1, and that's why this one is choice A. Number 7. 2 to the 3x. F of x equals 2 to the 3x power. And they want to know, what is it? What is it? I think what they're getting at here, they want to know about the graph of it. So 2 to the x, without the 3 there, would have 0, 1, and 1, 2, and 2, 4. But when you put this 3 here, what that generally does when you change the x into 3x is it makes everything kind of horizontally compress. Like the x value gets divided by 3. So it's a horizontal dilation. Interesting. This is a little bit ambiguous because with exponential graphs, horizontal dilation, you could get it multiple ways. You can get to this new curve. It's not a vertical dilation, though, because it still has the point 0, 1 on it, and a vertical dilation would move that x-intercept, or that y-intercept up. So we're down to these two. Now, which of the two is it? Well, you can rewrite this as 2 to the 3rd to the x power. There's a rule that when you multiply exponents, when you raise a power to a power, you multiply the two exponents together. That rule also goes in the other direction. So I could rewrite it as 2 to the 3 and then to the x, which is the same thing as 8 to the x power. And that's why the answer, I think, is choice C. Number 8. H models a periodic. Periodic means it's like going over and over. The minimum value is 8. Okay, so they're talking about like a sine curve, or cosine curve. The maximum value is 8. So let's just put this 8 up here. That's the max value, which it happens at time 0. So they're telling us there's a point right here. And the period is 12. So that means it gets back to 8 at 12, and which could be the expression. They don't tell us the minimum at all. So notice how these all have the same midline at 4.5. So what they're getting at, first of all, it's a cosine curve because this thing is going to look, something. Maybe it looks like that. Maybe it looks like that. They don't tell us anything, but it's definitely a cosine curve because it starts from its high point. The period is 12, and that makes the b value 2 pi over 12, which is pi over 6. And the 4.5 in the middle and the 3.5 there, that could have been a problem, but they all have that, so we don't have to worry about it. But the fact is 4.5 plus 3.5. If the middle line is 4.5, the amplitude has to be 3.5, so it gets from the middle to the high point. Number 9, data that appears exponential is modeled by the function 7 times 5 to the t power. The data are represented. I always think that it wouldn't be so bad if we said is. It sounds like you're saying it wrong. You say the data are, but actually data is plural. Singular of data, datum. Semilog plot. So 7 times 5 to the x, 5 to the t power, looks like this on a basic xy, where this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But a semilog plot is where you would have like 7, and then 49 would be the same distance because it's 7 squared, and then 7 times 7 times 7, whatever that is. And what happens is when you graph the same points that look like a exponential curve on regular graph paper, those end up looking like a line on semilog. So the data appear linear. But the question is, which of these two is it? So let's look at the points now. 7, 0, or 0, 7. And this next point is 1, 35, which is over here. Because if you put 1 in, you get 35. Now, I think the answer is B. So I think the answer is, wait, I gotta make sure. You know what? Interesting question. Interesting. I gotta think about this. I never thought about the slope. Well, it's one of these two. Which one exactly? Is the slope 5? Well, I got to think. I'm going to pause and think and come back. Okay, I'm back. I think the slope's ln 5 because that's like a small number, whereas slope of 5 is pretty steep. So, and if this goes like 7, 49, like to get a slope of 1, it would have to be a 7 to the x here. That would be to get a slope of 1. So I think the answer is B. It's either A or B. Okay, in this question we have a sphere that can expand. Why not just say it's a balloon? Come on. As it expands, the volume and the radius of the sphere both increase. In particular, the radius increases at a decreasing rate. Which of the following graphs could depict the situation where volume is the independent variable and radius is the dependent? Wow. So what they're saying is that the radius starts at 0 and it goes up, but it increases at a decreasing rate. It means it kind of goes like that's what happens to the radius. It's increasing at a decreasing rate. Now, got to make sure that's what they're asking about here. Which could depict, the volume. The volume increases. Yeah, I think it's this one. I think they're basically asking about concave down. It's increasing, the radius is increasing by a lot at first. It goes from 0 to gets bigger, but then the more air you put in, the thing's already kind of large, so more air doesn't increase the radius by very much. Number 11. You might suspect I'm seeing these questions for the first time. There's no rehearsal. This is just a first look. What's it called? Box opening? Unboxing. The location of a point in the plane is given by this. So that point, so here's polar graph paper. 2 pi over 3 is the same thing as 120 degrees. So I'm facing in the 120 degrees direction, but it's negative, so it ends up over here in quadrant 4. They want to know which other point has this same thing. Well, there's a lot of answers to this, but I think this point, if I just saw this point regular and I wanted to describe it as 3 comma something, this angle would be 180 degrees more than this angle. So the angle here is 120 degrees. But if I go 180 degrees more, I get to 300 degrees. And 300 degrees in radians is 5 times 60 degrees. 60 degrees is pi over 3. That's why the answer is choice A. 12, we have a table which best models the data. So you notice these numbers all go up by 1, but these go up by 13, and then suddenly this one's going up by 51. Whoa, and this one's going up by just 21 and 23. Interesting. And 25. So it's not linear, but it's also not quadratic, because if you do these differences now, you get 38. This one you get negative 30. And then 2. 2 again? Yeah. So basically, if you do it again, so it's not linear and it's not quadratic because there's not constants. But is it exponential or polynomial greater? That's interesting. So exponential, it's kind of the difference gets sort of bigger each time, but this is also getting smaller sometimes. So like if I were to graph this thing, it isn't looking like that. It's going from 15 to 28 to 79 to 100. It is going up each time, but it's going up in a weird kind of way, and that's why I think it's polynomial greater than 2. Number 13, the height of a point can be modeled so sinusoidal function. That's kind of like, like that. Okay, what do they tell us? If h is positive, the point on the dolphin is above the surface, and if h of t is negative, it's below. So this thing is like going above and below water. It jumps, as it swims, it jumps to a maximum of 3 feet above the surface, then hits the surface and dives to a minimum height of 3 feet. So we're talking about like that. It's going from 3 to minus 3. So there's not going to be this thing because this curve has a middle line at 0. The cycle repeats every 4 seconds. So if the period is 4 seconds, if that's 4, 2 pi over 4 is the b value, which is pi over 2, which is why the answer is choice A. Number 14. So let's look at this. Interesting. So there is a formula for the cosine of A minus B, which is cosine A cosine B minus sine A sine B. Cosine A plus B has a minus here. And if I do cosine of A plus A, which is 2A, I get cosine A minus sine A sine A. And this is a trig identity, cosine squared A minus sine squared A. You could always replace, if you see this, you can replace it with cosine of 2A. And here I see it, cosine squared minus sine squared, so I can replace it with cosine of 2 times 2 pi over 5, which is 4 times cosine of 4 pi over 5, which is one of the choices. So you'd have to know this trig identity, maybe this one, or you could derive it. 15, the population is decreasing over time. So we have this kind of situation, years since 2000, based on so they have this equation. Then they have an updated model. The new model was given by this instead. It's a different model. Which of the following describes the relationship? So the first one has a b value of 0.92, so it has a decay at a certain rate. But then there's a 0.9, which makes the decay even more, so it's kind of going like that, I would say, the new one. Because basically we're changing this number to like 0.8 approximately. So we want to compare if you have 0.9 to the t power versus 0.8 to the t power. 0.8 to the t power means it's more of a percent is getting removed each time. Instead of 8%, like 20% is getting taken off. So I would say in the new model, the growth factor is, the initial value is still the same. Because if you put 0 in, you still get 20,000. The growth factor is reduced. Yeah, it's the growth factor. It's smaller because 0.8 is smaller than 0.9. I'm going to say A. Okay, let's look at number 16. Consider a circle. Why do I have to say it that way? Why don't you say there's a circle? We have to say consider a circle. So we have a circle. Pi over 4 is radians is a fancy way of saying 45 degrees. Standard position just means that one side is the positive x-axis and the other side is when you rotate it 45 degrees counterclockwise. The angle is subtended by an arc. Okay. So the arc is 40 units, and they want to know the radius of the circle. Well, there's a formula. Arc length equals r times theta, where the arc length is given. The radius is unknown, and as long as the theta is in radians, which it is, multiply both sides by 4 over pi. And get 160 over pi, choice D. 17. Here's a function with a lot of sines and cosines, and they want to know the zeros of g. So basically, when does this equal 0? Well, it equals 0 anytime the numerator is 0. So 1 plus sine x has to equal 0, or sine x has to equal -1. Now, I personally picture this and see that here at 270 degrees, which is the same thing as 3 pi over 2, that's the one place where it happens, and that's why the answer is choice D. You might like to picture a unit circle, and when is the y coordinate equal to -1? Again, it's at 270 degrees. 18. The number of people waiting in line is modeled. So the idea is that here's like 45, and it goes kind of cosine curve, so it kind of goes like that. So there's a lot of people in line, no one's in line, or fewer people are in line, more people, and it goes in like a cycle. So what's true? Well, the number of people is never equal to 0. That's true. Because 42 plus, 45 is the midline. Then you go up 42, down 42. So the minimum is 3. It is never negative. Oh, but why? It's never negative. It's never 0 because the amplitude is greater. No, it's because the midline is greater than the amplitude. Because the 45 is bigger than the 42. So it is A. 19. Rational function. Ooh, slant asymptote. We don't see that much. Do you know that this question is a little bit easier if you factor it? These x's cancel. That makes a whole a 0. This numerator, it doesn't factor. X squared minus x minus 4. So the slant asymptote is what happens if you divide the denominator into the numerator, which I'm going to just do with long division. X times x is x squared, so it's x squared minus 4x. Subtract. Confusing here, minus x minus -4x is minus x plus 4x, which is 3x minus 4. And then plus 3, because this x times 3 is 3x, so 3x minus 12, subtract those. Careful here, minus 4 minus -12 is plus 8. So plus 8 over x minus 4. The slant asymptote is this. Basically, this means that this curve has some kind of, maybe it goes like that, but there's a slant asymptote. They wanted to know the slope. Well, the slope is 1. Y-intercept is 3. 20. F of x equals sine x, so that looks something like that. G has the same amplitude as f, which is 1, and the period of G is half the period of f. So that means that this G curve goes like that. So the period, so this is a horizontal compression, and horizontal compressions happen when you multiply inside the parentheses, the x becomes a 2x. That's what causes horizontal compression. So the answer is C, not A. A would be if the curve looked like that. 21, binomial theorem, x plus 3y to the 5th power. Wow, they want the whole thing? So x plus 3y to the 5th power has 6 terms in it, so that's why this is out. And this has 1, 2, 3. The rest of them have the 6 terms. Every term, a good thing to do with binomial expansion is to make a little Pascal triangle. You just add these two numbers together to get this one. So 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. These become the coefficients. As you can see, already the answer has to be D. But if you're not sure, like how does the rest of it work? You take the 1, put it here, then you take the x and raise it to the 5th power, and the 3y gets raised to the 0 power. Then you take the 5, and the powers on the x's goes down by 1, but the power on the 3y's goes up by 1, then the 10, and as you can see, it's creating choice T. 22 is particularly annoying and much more difficult than it needs to be. They want to know how is the distance between the origin and the point with polar coordinates changing. What they're getting at in this question is there are polar curves that go like that, which means that it starts off, the distance to the origin is some number, but then it gets kind of smaller as it goes. Then there are curves that do the opposite, where it starts off close and it gets bigger as it goes along. I think, whoops, not like that, like this. I think of it as spiraling in versus spiraling outward. So, erase all ink. This particular curve is really hard because it's got the negative and all that. Probably going to be some kind of limosone with inner loop. There's like that kind of curve or that kind of curve. Let's see. What do they want to know? Okay. So there's a pretty easy way, I think, to do this now, since they're telling us there are other questions where they want to know in which region is the distance between the point and the origin decreasing or increasing, but not this time. They just really want to know what's happening in this small interval between 90 and 180. So what I would do is work out f of 90, which is 1 minus 2 cosine negative 90. Now cosine of negative, or if you like to say pi over 2, cosine of negative pi over 2 is 0, because cosine of pi over 2 is also 0. It's like 90 degrees. So this becomes 1. But f of pi, if you put pi into this, cosine of negative pi. Now cosine of pi is negative 1. Cosine of negative pi is also negative 1. So this becomes 1 plus 2, which is 3. So what happens is that the function value, if I were to graph it, I would go from, at 90 degrees I'd have 1, but at 180 degrees I'd have 3. So it's spiraling outward. And that's why the distance is increasing. That's the answer for that. So that was easier than I thought, because often they ask this question, they ask in which interval is it increasing or decreasing, but this time they gave us the interval. 23. Now, a little editorial. These videos are just done sort of improvised. I'm only making them because this year, 2024, is the first time this test is ever given, and there's no practice tests or there's just these sample tests. There's no actual tests that have ever happened, so I just want to make these videos for my students. If you want to see other better videos, just look at other videos on my channel. So we have function f is this, simple function, linear, and g of x is quadratic. And they want to know, what about the quotient? Equals x plus 1 over x plus 1, 3x minus 4. So this is the kind of thing with asymptotes maybe, or wholes. If you can cancel out a factor, it means there's a whole at x equals negative 1. So this is out, whole at negative 1. But the denominator doesn't have anything to cancel out, so that's an asymptote. At 4/3 would make this equal to 0. That's out, it only has one whole. Yeah, so it's this one. It has a whole at negative 1, because there's a common factor. So they don't want to know about the asymptote at all. So it's choice D. If you can cancel it out, it makes a whole. It means that at negative 1, it would look like that. If you plug negative 1 into this equation, you get 1 over negative 7. So it's actually down here. But that's what it would look like. Whereas there's an asymptote at 4/3. So it might look something like that. 24. Secant and cosecant. What's true for both of them? Well, so secant is 1 over cosine. Here's what cosine looks like. And secant's the reciprocal, which gives it asymptotes where cosine was 0. So secant looks something like that, like these upside down parabolas. And the domain is not all real numbers, because there's these undefined things where cosine was 0. Cosecant is the reciprocal of is the reciprocal of sine. It also looks like these upside down or regular parabolas, and it's got asymptotes also. So the range, yes, both of them have this in common. The y values are either above 1 or below negative 1, and that's true for both of them. They have different asymptotes, so nothing about the asymptotes are true for both simultaneously. They're true for one or the other. 25. Both non-zero functions are invertible. The input of f are times in hours. For which of the following? So f converts hours into rates. F converts hours into rates, and G takes rates and turns it into costs. And they want something that's the input is costs. So we're going to want, oh, I see. The inputs are costs and the output is time. So the only one that has costs in it, right, because F is rates in miles. So we definitely want to have a G, but G converts rates into costs. So G inverse would turn costs into rates. And then I want to turn rates into hours. Well, F turns hours into rates, so I need an F inverse here also. I don't really like that question, but that's the answer to it. 26, here's a function value, and they want to know f of x minus 1 plus 3. So what this does is it's kind of a funny question. I'm going to actually show you how this works. So if you put, I notice how all of these have a 0 in them at least. So I'm going to put 0 here. Now h of x is f of x minus 1 plus 3. Now when x is 0, x minus 1 is negative 1. So f of, I'm just going to go like that. When 0 is 8, this is h of 0 is f of 0 minus 1 plus 3. But f of 0 minus 1 is f of negative 1 plus 3. But f of negative 1, according to this, is 0. So 0 plus 3. So I should have 3, and that's why the answer is this. I think what they're trying to get at is that the function shifts to the right by 1 and up by 3. So every point gets shifted right 1, up 3. I think that's what they're trying to get at. So when that happens, this minus 1 would become a 0, and the 0 would become a 3. I think it's a transformation question, but I kind of cheated by just picking a value. The graph gets shifted 1 to the right and 3 up. So for each point, 1 to the right goes to 0, 3 up, 1 to the right, 1 to the right, 1 to the right, 3 up, 3 up, 3 up, which also totally agrees with that one. 27. Here's some points that would be on like a scatter plot. 1, 3, 2, 4.5, 3, 5 point something, 4, 10 point something. And then there's some kind of a two function models, linear and exponential. So if I were to take this model and try to make a fit a line of it, I get some residuals, meaning like some points are above the line, some are below. But if I do it instead with an exponential, the points are right on it. This thing is definitely not linear. So a line of best fit is not going to fit that well. And that is why, in this case, the exponential is better. Linear is more appropriate, no. So exponential is more appropriate, and residual plot 1, residual plot 2 is, residual plot 1 is the exponential one, because that's the one where these dots all fit on here, which would make the residuals all 0. Whereas if I take the same exponential data and try to fit a line in, some are below and some are above. So the sort of distance above or below ends up becoming the distance above or below this horizontal line. And finally, question 28. Here's a polar function. They want to know what the equation is. So that's kind of funny because if you put 0 degrees in, cosine of 0 is equal to 1. So 6 cosine 0, if you put 0 into either of these, you would get 6 cosine 0, which equals 6. But there is no point here, so it's definitely one of these two. Now, what I like to do for this is take this point. That point's at 6. 6 happens, sine of 45 degrees, or pi over 4, is equal, in general, sine of 90 is equal to 1. And 6 sine of 90 is equal to 6. But this 6 is occurring at 45 degrees, which means I'm going to have to put a 2 here in order to move that point from there to there. In general, if it's if there's an even number of leaves on one of these rose curves, if you divide it by 2, it tells you what the coefficient is. So I'm just going to make a note here. When theta is equal to pi over 4, which is 45 degrees, 6 sine of 2 theta is the same thing as 6 sine of pi over 2. Sine of 90, or pi over 2 radians, is 1, so 6, so it agrees with this, whereas this one, it would not agree, and that's the answer to that question. Again, apologize for the quality of this review, but I'm doing it just because my classes are taking this test in a few days, and I want to give them something, but I'll probably be deleting these one day because I don't know if they're good enough. Okay, bye everybody.